Hello everybody, my name is Alexander Haley. I'm a sophomore of electrical engineering and it's my privilege to give you all a tour of the LeTourneau Circuits and Measurements Lab. If you are studying electrical or computer engineering, you'll spend a fair amount of time in this lab as several of your courses are taught in here. Students' introductory experience to the Circuits and Measurements Lab comes from its namesake course, Circuits and Measurements Lab. The Circuits and Measurements Lab course is taught in conjunction with the Electric Circuits course to give students the hands-on application of almost all of the theory that they've been learning in their electric circuits class. The Circuits and Measurements Lab class does this by giving students experience with data acquisition tools such as oscilloscopes, multimeters for the benchtop power supplies, data acquisition systems such as the NI Elvis, and also writing LabVIEW VIs to control the data acquisition systems and automate several aspects of the data acquisition process. Later on in their course sequences, specifically for electrical engineering students, they'll also have a class called Advanced Electronics in Lab, which is also taught in here. And that class is almost entirely focused around the application of the theory that they've learned in their circuits classes to design, build, and test a benchtop power supply. But to give you a more brief idea of what this lab is capable of, I've rigged up a small demonstration here involving solar panels. This setup right here will optimize the power transfer obtained from the solar panels for use in various circuit designs. The quick version of the theory behind it is that when the impedance of a generating source is matched with the impedance of a load to that source, the power transfer is maximized. So this setup here works briefly by using a resistor substitutor box and a data acquisition system that is measuring voltage at various points in the circuit, which is then fed into a LabVIEW VI, which does some calculations to generate a graph of solar panel power output with respect to the load that's applied to the solar panel. Running a trial looks like turning on the lamp here, running the LabVIEW VI, and spinning the dials on the resistor substitutor box. As we can see here, the data is a little rough. That's because more time translates to more data that's able to be collected. You'll also notice that there's a fair amount of error as we get toward the center part of the graph. That's because the data acquisition system and solar panels are picking up the 60 Hz flicker in the incandescent bulb due to the 60 Hz alternating current that is being powered with. Even still, we're able to get a fair amount of good data here. We can see that about 160 ohms, we get a maximum power transfer of about 125 milliwatts. This data can be used in conjunction with some of the math that students have been taught in their electric circuits course in order to optimize the power of a handheld design or another design involving solar panels. So this is just a very brief version of what the Circuits and Measurements Lab is capable of. My name is Alexander Haley, and thank you so much for touring with me today.